It is time for a brand new epic product launch. Okay, we go to Scotland, we go to UniKLasers. They're going to talk to us about a world's first single frequency ultra narrow line with 349 nanometers DPSS CW UV laser. Thank you very much for being with us from UniKLasers, a vertically integrated company. When you go there, you see the entire manufacturing chain. One of these companies that I know is the success of Europe in their hands. The floor and the attention of everyone goes to Johnny Bray, the head of sales of UniKLasers. The floor is yours.
Hello, Jose. Can you see my screen?
Crystal clear.
Fantastic. Thank you very much for the introduction. And hello to everybody. Welcome to my home on the east coast of Scotland. It's probably the most strangers I've had in my house for about 18 months, so I'm excited to welcome you all. I'm going to give you a short introduction into my company, UniKLasers, and a short overview of some of our technology, and then finally the new product that I'm here to announce, which is the world's first single frequency continuous wave DPSS laser operating at 349 nanometers. So as a quick introduction into who we are a small but growing company based in the capital in Scotland. As a personal note, I joined the company on the back of both private and national investment in the past 12 months. Incidentally, probably the last time I had a haircut as well. We've moved into new premises. We've looking to commercialize now some of the research that we've been doing for the past few years since our foundation. What we specialize in is the development and now production of continuous wave single frequency DPSS lasers, diode pumped solid state lasers. And to do this, we use our patented BRAMS technology, which I'll explain to you in a few slides' time. What it allows us to do is to create these solid state lasers with a very small footprint, very, very high stability, both spectrally and in power, at very, very low line widths. So as a quick background, we were founded by Professor Fedor Kapushko, the rather disappointingly handsome young man standing on the left of this photo, next to Professor Stepanov and Professor Prokhanov. Professor Kapushko has been involved in lasers literally since their invention by my man back in the 50s. He has over 150 publications, and it is this BRAMS technology that is the culmination of all of these years of research that UniKLasers was founded to commercialize. Historically, a research company, we have a wide academic, commercial, and national partnership. So we work well with large corporations. I'm sure we all know well within the EPIC network, people like Fraunhofer and Teledyne. We have a lot of funding from people like Technology Scotland and Innovate UK, and we work widely with a wide number of academic partners as well. Not least to mention the EPIC network. Our company is founded on BRAMS technology, so we have a simplification of our laser cavity here. Both the reflectors overlapping the gain media. You have a non-linear crystal, which is an optional step depending on which frequency you're looking to produce. And BRAMS technology in particular is this section on the right-hand side. We use a volume Bragg grating to restrict the number of possible modes coming from the gain media. And then we use quite old technology, a Michelson interferometer, to finely tune this reflection and limit the gain media to just a single longitudinal mode. We then lock this using a tilt locking mechanism with these mirrors that control the cavity length. This gives us a unique method of single frequency generation. It allows us to skip some nonlinear steps. We can have more direct access to lower wavelengths, which gives us higher power and higher efficiency. And we also have very highly stable products in this way. So currently, the combination of our research over the past 7 years has allowed us to produce a number of different wavelengths. To give you a few examples, we have our Solo 1064. It has a very small footprint. It's around half the size of a piece of A4. A solid state laser producing up to 2 watts of output power with extremely low line width and extremely high stability across its range. As we move down through the wavelengths into the 640, we can see we maintain these specifications, and an example of the performance along the bottom over 24 hours we have this very high wavelength and power stability, and also excellent beam quality as well. We have lasers at 532, and all of these are used in a range of different environments. I know all of us like to look inside academic labs. So here's an example of one of our customers in Germany is using the very high spatial resolution of our lasers in conjunction with confocal microscopy and Raman spectroscopy to return very good results. The one thing I haven't mentioned is our quantum technology. Our main research basis is around quantum technology and quantum sensing. So the continual improvement, miniaturization, and increased reliability of these narrow line width sources that are suitable for different quantum technologies. And commercialization of this research is really what our products that I'm introducing to you today are founded on. Last and not least, as a concept of this technology within the UV range, we've released the Duetto 349 laser series. As a quick oversight into our naming conventions, you notice we have the Solo and the Duettos. The Solos are direct laser sources. There's no non-linear step, whereas the Duetto, the 349, gives you the idea that we can access the UV region using just one non-linear conversion, which allows us to keep the footprint very small and also allows us to have very high energy efficiency as well. I showed you some power stability before, ran over 24 hours. Here's an example, ran over an entire weekend. So something like Friday afternoon to Monday morning. You can see we have this very, very stable output power of less than 1% and this unbelievable wavelength stability of just 0.06 picometers across 65 hours. The whole unit has been arranged and designed for this type of integration to different systems. The wavelength gives us access to a wide range of applications, both industrial and academic. We've made some considerations for the coronavirus. We have remote diagnostics and software control. We do not need to travel to connect to the laser. And we also have very long operational lifetime as well. I hope that gives you a quick background into the company and the products we produce. Thank you for listening to me. I'm happy to answer your questions.
Thank you, Johnny Bray. Johnny.bray@UniKLasers.com. Please send him any kind of request for this fantastic two products that he presented. I would like to go first to the, Solo 1064 laser series. I'm going to ask you the same question I ask all the time. This is a product release. So how is this product different from the competition?
Yeah, so the main uniqueness, and this is a pun that I am contractually obliged to make at least twice every presentation that I do for UniKLasers, is our technology basis. So we use our Brahms technology to produce very high power at very low line width, very narrow line width at single frequency. And this combination of small footprint, high output power, and very narrow line width is what makes our lasers unique to other lasers on the marketplace.
You have defined for the Solo 10, well, actually, maybe I should say the screen. For the Solo 1064 laser series, you have defined microscopy as one of the particular application fields. From all these different application fields that you are targeting, which is, in your opinion, the two or three main ones, and what kind of system integrators you think EPIC should bring you in touch with?
Yeah, so in particular, the new product launch of the Duetto 349 really opens up the variety of applications that we could target and focus on. So the specification of narrow line width obviously lends us to applications where high energy selectivity is important. But as we move down through the wavelengths, which is very much where our product map is headed, down into higher energy and lower wavelengths, we can use this spatial selectivity as well. So the example that you gave of microscopy is an ideal type of application for these type of laser sources, especially down at the lower wavelengths. So things like high resolution Raman spectroscopy, where you need very good spatial control over your feature size, but also clever control in the Z-axis as well, using a highly controlled, precise laser like the ones that we produce is ideal for these types of things. So
We talk also about the area where you are, Glasgow, and quantum technologies. There's been a huge amount of developments on quantum technologies in Scotland. What is the key application field that you are targeting? Is it an atomic transition for atomic clocks? What is the one or two maybe applications in quantum technologies that the researchers in the room should really contact you for buying your laser?
Yep, so quantum sensing and metrology are the particular applications that we focus on. So I know quantum technology is an area of great excitement. We know that it will be implemented across many different areas in the next, depending who you ask, 3 to 7 years perhaps. And you read the BBC and other news services where you see groups of university students wheeling out gravity detectors out into the field, and these types of things are finding lots of applications in building and oil and gas and exploration and archaeology. Our national research projects are designed to allow us to provide a light source that is suitable, small enough, robust enough, and with the correct specifications to fit into these type of applications.
Congratulations. I would like to highlight that UniKLasers is really a vertically integrated company. They do all the manufacturing in Glasgow, and they're always looking for partners. So this is a huge opportunity to collaborate with what is becoming a success story on the DPSS lasers. Johnny, once again, thank you very much.